welcome back, everyone. Let me just pull up my agenda. We are bang on time, and now we've got half an hour with Ross Holleran from the Building Performance Network. So we know Ross a number of years now in various guises. He's always been our kind of go-to man in terms of the networking side, particularly around building performance, and he's got exceptional presenting skills whenever I've seen him, and he's very capable of pulling together large networks of people, which is clearly what his current role is as well. So Ross leads the Building Performance Network in terms of gathering the momentum, I think it's fair to say, for the BPN. And with the Building Performance Network, we were part of it at the University of Salford in its creation, and we still are part of it, and we'd like to see it grow, and we'd like to see it go from strength to strength. And that is now what Ross is going to share with you, his plans on how that's going to happen. Thanks, Ross.
Thank you, Richard. You make me sound like a Scarlet Pimpernel or something, working from one place to the next.
I just meant you're incredibly successful, Ross. That's what I meant.
Or a fly-by-night, one of the two. So welcome, everybody. I noticed that there's kind of 50 people have come back after the break. I'm amazed. I'm really impressed. I thought everybody would listen to Luke and then not need to listen to me. But a quick introduction. Yes, my background is industrial design, process improvement, and working at BRE on a number of Innovate UK projects. And then more recently, I've been working with Canal Insulation in Belgium, where we set up and launched a what we would call a smart housing retrofit service, where we did a design and delivery approach, but it also included building performance monitoring before and after heat loss coefficient validation and monitoring. And my side of the challenge was to create the quality controls and the processes from design, procurement, training, and delivery to try and make sure that performance gap that Luke highlighted before, it was as small as possible. So my work with the Building Performance Network, which is a not-for-profit organisation, and as Richard kindly introduced, our aim is to raise awareness from policymakers all the way down to actual practitioners of the really great innovations and changes that are happening within this field, and try and help show that it can become mainstream. Because one of the things that you no doubt will all be very aware is that if you just knock on government's door and say we should be doing building performance evaluation on every building, and they say, well, how much will it cost and how many homes will it slow down the delivery of? If you don't have good answers to that, then you don't get anywhere. So the aim of the Building Performance Network is to prove that it is possible at scale. It can be delivered without negatively impacting profit margins, and actually it can bring new business opportunities in and of itself. So I'll try and cover some of those things. It's quite a different take on this subject than Luke's and Tom's that will follow, but hopefully you'll see some threads that come together. So what do we see? The world is rapidly changing, and it's moving away from co-heating tests and very invasive building performance evaluation that we used to know. The State of the Nation report, you can see just the screenshot of on the left, Luke very kindly referenced, and it showed that work is underway, but as he quite rightly pointed out, at a scale that is a pittance compared to what's required. And I think that's really a reflection of the fact that many of the techniques we have had in our toolkit for building evaluation are highly invasive, expensive, and akin to end-of-line testing in other industries. So it's almost like we've been doing an NCAP test, a crash test on buildings once they're produced and said, well, it failed. And we couldn't root cause analysis work out why those things were going wrong. So the types of techniques and technologies that Luke and Tom have been explaining are giving us different things that we can use to produce inline checks and quality controls. But there are lots of other things that are taking place around the built sector, and I'll touch upon some of them, that mean innovations are happening at a pace that we've never really seen before, and we're almost accidental beneficiaries of other things that are happening. We need to think about who's going to see great value or greater value in these building performance evaluation, and it might be some people that you're aware of, but actually they're bigger players than we initially thought. there are new opportunities to build a business or extend your current business offering into this area. And also, I'll just touch upon some of the changes in the policy landscape that will help make this mainstream. The big caveat, obviously, is that it's very difficult when there's lots of innovation taking place to actually predict the future. So those of you that are over 40 see this as a Tomorrow's World presentation. Those of you that are under 40, then your favorite YouTuber that dreams about what the future might look like. I'll give you some indications of the trends, but I can't promise that what I tell you is absolutely what will happen. So what do we see? We see that data streams are coming from buildings in a way that we've never seen before. So it used to be that a building was a static object that existed of itself and drew energy from the core network, from the gas grid network or electricity. But over the last 10, 15 years, we've seen it start to generate its own energy through photovoltaic, solar thermal. And through the last maybe 5 years, we've seen that thing that Luke touched upon, this idea of the Internet of Things. So a lot of the products and systems that are in our buildings now are constantly communicating with the cloud, as people call it. And what that's really allowed people to do is start to prepare for the future way that buildings will become part of the energy system, the energy network. And the reason that's important is that people such as energy providers and insurance companies and investors in the stock for portfolio management and what have you, for pension funds, are now becoming acutely aware that the way buildings perform influences the wider network. So they want to know how the building is performing, why it's performing in the way it is, what it's doing, and what the bigger impacts will be. And that goes beyond just simply energy, which is where I arrived, but it starts to look at indoor air quality, occupant safety and happiness, how the building is either generating or storing energy, its ability to separate when it needs energy and when it draws it from the grid is absolutely critical. And the reason I'm telling you this is that these people, these companies, are injecting huge amounts of R&D money into making our buildings smarter. And we, as the building performance sector, can actually take advantage of that. So we can ride on the coattails of these other areas of innovation. So what does that begin to tell us when we look at the future marketplace? Well, the way that we at the Building Performance Network have begun to try and structure this in our own minds, I suppose, is that you can see the building as a product. So see this almost as the traditional way that we look at buildings. You either create them new or you retrofit them. And as the designer or the architect or the product manufacturer, your relationship with that building ends when you hand the keys back or somebody moves into it. There's also building as a service, which is people who have a longer relationship. So maybe owner occupiers, but also facilities managers, warranty providers, insurance companies. But what does that actually mean in terms of building performance evaluation? Where do these different groups see the value in the data and the information that we can provide to them? Well, for the examples on the left, which is a slightly more traditional view of the world, the data and the analysis that we can do in terms of building performance has value because it can de-risk their innovations. They can differentiate through quality, so that touches upon modern methods of construction or alternate building products that Richard was talking about, the type of people that work with Salford University and other groups, that they can prove that their products can perform in the way that they claim they can. And other people, such as building control bodies and some contractors, can use building performance evaluation to demonstrate compliance with regulations or with funding requirements. Where it starts to get a bit different, and arguably we start to see the real changes happening, are when we start to look at the building as a service. So here we see value from understanding whether the occupants are comfy and healthy, about predicting maintenance. So we hear a lot of stories, for example, in the aviation industry, that Rolls-Royce know that one of their engines will fail 2 months before it's actually failed, because they can see a signature in the data that comes from every jet engine that flies around the world, prior to COVID, obviously. But as Luke was mentioning earlier, heat pump manufacturers, ventilation manufacturers, solar thermal and photovoltaic and battery manufacturers are embedding sensors and technologies into their products by default for their own reasons, that are streaming data that we can tap into to learn more about the buildings. And one of the key things that we're seeing really changing is, as many of you, probably all of you will know, the shift from gas is about to happen in terms of building space heating and water provision. We're moving away, I believe it's from 2025 for new build homes and probably other buildings, they need to be completely off gas. And for existing stock by 2050, so let's say by 2030, you'll see ramping up that sales of high performance gas condensing boilers will tail away, and some types of heat pumps and electric heating will come in. If you overlay that with the shift to an electrification of transport, you see a huge spike in demand in the electricity grid. And one of the things that is being predicted is that the network won't be able to support it. So you do one of two things. You either reinforce the grid and put loads of new substations and loads of high voltage networks in, and there's a certain finite capacity for that, or you start to use the grid intelligently and you use buildings as a way of shifting peak demand. So by that, what I mean is that we all know about the spike at 6 o'clock in the evening where people come home and they start cooking, they start putting kettles on. Imagine that spike amplified by the fact that heat pumps will start coming on, and that people will return home and plug in their Tesla or whatever else it is, and you want it to charge quickly. The figures I've been hearing from the network providers is typically a home at the moment will have a peak demand of, let's say, 2 to 3 kilowatt peak. If you put that home and it's got a fairly good fabric onto a heat pump, that might go from 2 to 3 to 5 to 7. If you then put in a high-speed electric charging system for a vehicle, it might go from 7 to 8 up to 12 to 15. So you suddenly see that those spikes become incredibly important. And with clever data and clever systems in your buildings, you can flatten those spikes, smooth those peaks. So all of those requirements for data and control that come from the energy network actually are of real benefit to us to understand how buildings are working and improve their performance. What's interesting as well is when you start to look at different pieces of data have different value and therefore worth to different people. So that can sound a little bit esoteric and a bit kind of fluffy business talk. What it actually means is, if you look at some of the early work that's coming out from a European project that I know Luke and Richard are very closely involved with, which is about characterizing building performance with monitored data, they did some European-wide market research into, in this case, fabric performance testing. So this is the heat loss coefficient, the heat loss parameter that Luke was mentioning. And the marketplace, which included energy providers, architects, owner-occupiers, fed back in this consultation that most people wanted a test that was within a day to less than a week. So they would accept testing for that period of time because it wasn't too invasive and it didn't cause too much disruption. They wanted an accuracy of between 5 to 10%. So this is a common story. They want it to be less than a week, an accuracy of 5 to 10%, and that it was a valuable test to them. They could rely on the data. But what gets really interesting is when you look at what they said they were willing to pay to get that data as a service. If you look at the contractors, and you might say this is the old world, so people that view buildings as a product, they said, really interesting data, I'd pay between 100 and 500 pounds for each test. That would be great. When you speak to the ESCOs, so that's energy service companies, so people that have a long-term relationship with the building, they'll say, we'll take over the operation of this school, hospital, maybe even this estate of houses, and we'll do that for a certain fee. For them, clearly, it's very important to understand how that building or those buildings are performing, because it has an influence on profit margins and on their business model. So they're saying that they would be willing to pay for the same data up to 4 times as much as the contractor. So why is that important? Well, stating the blindingly obvious, if people are willing to pay more for a service, you can either make more profit margin, you can do a better job, or actually you can start providing a service to a certain sector that you couldn't to others because it's too expensive. So for me, that's really exciting news, that you see there are people who are beginning to see building performance evaluation and data as really valuable to them. And they're actually some of the people that are also almost unknowingly providing the innovation funding we need to provide them that data. So that's a really exciting trend that appears to be coming out from the research. So is this all just pie in the sky, or is it actually beginning to happen? So there's been some reference to PAS 2035. I'm not going to go into loads of detail because many of you, I'm sure, were on previous seminars and you probably know better than me what's in there. But in short, PAS 2035 is the companion guidance requirement to PAS 2030, which is all about improving the quality of domestic retrofits in the UK. And why is it important? Because energy supplier obligation funding, government funding through BEIS, all require the use of PAS 2030 and PAS 2035 from, I believe, this summer. And PAS 2035 is about designing, procuring, and delivering high quality retrofits. And a key part of that document, which in a way is, it's not an afterthought, but it's the beginning of something very important, is that it requires evaluation. And if you speak to the PAS 2035 team, they say it's about a comparison between design expectation and delivered performance. It's not about very detailed U-value calculations and kilowatt hours per meter squared in every case, but it's about beginning to formally close the loop. And if you think that you have to, on every property, carry out a questionnaire with the client and the occupant about, did this project, did this retrofit deliver the improvements that you were expecting within 3 months of the project completing? If the answer to that is no, it was slightly different, there's been some mold growth, or the house feels like it's still cold, or it seems to be running the boiler very often, or I'm not seeing the output from the PVs that I was expecting, then you take this tiered approach where you have to go to the next level, which is an intermediate evaluation. So here you start to see quite a significant ramp up of activity. And for me, this is building performance evaluation. So you have to do a physical inspection of the building, you have to do air pressure tests, energy monitoring, internal temperature and humidity testing, depending on what the faults are believed to be. So if somebody says, yeah, there's lots of mold growth in the bathroom, you might not necessarily need to be doing energy monitoring, but you would be doing more internal temperature and humidity testing. That's within 6 months. If you've still got problems, an unhappy client or an unhappy occupant, then it goes to the ultimate tier, which is within 2 years, you need to run a complete construction review. So that's talking to the design team, the product manufacturers, reviewing any evidence of what was built during the contracting phase, post-occupancy evaluation, thermography, all the way to fabric moisture measurement. So this is actual interstitial moisture condensation analysis and measurement and sub-metering of the building. So that's not going to happen on every property. This is only really to make sure if somebody's done an absolutely woeful job, the work is improved. But it's written down into a standard that will be a requirement of all public sector funding. And you can bet, and it would be sensible, that if I was if I had responsibility for a social housing stock, a portfolio, then I would procure against these standards, because I know that the work should be done to a better quality, and I can refer to it and say, you wrote and signed up and you quoted and you won the tender against this. So for me, this is really an important early sign of what building performance evaluation will be in the mainstream. It won't ultimately look like this in the future, and the innovations that Tom and Luke are bringing to the market will mean that what initially looks like a hugely onerous, impractical regime will actually be quite quite simple and commercially viable. That's purely retrofit. If we look at what's coming in the new build sector as well, it's interesting that you see in the future building standard consultation, which just came out, so that's about non-domestic buildings. They build upon energy consumption metering, which is quite common in the non-domestic sector already, but also they start to talk about capturing data, actual performance data about indoor air quality, so relative humidity, CO2 levels, in time maybe, VOCs and ventilation rates. You might say that's a knee-jerk reaction to COVID and concerns about spread of viruses and what have you. But whether it is or not, for us as building performance evaluation industry, it's really important because it means there's an acknowledgement that those data streams exist and we can really start to use them to improve the building stock. For me, I think this is an interesting early sign that the worlds of the energy system, Internet of Things, a fundamental way in how we gather and capture data means that there's a saying out there for some apocryphal genius, which is why model if you can monitor and measure. And what we're beginning to see is, yes, we can, with these new technologies, monitor and measure much more than we ever dreamt of. And the other thing you often hear from previous generations of building performance evaluation people is, don't capture too much data because you just drown under a sea of information, which may have been true, but with the generation below me, who can use clever algorithms and machine learning, filtering the data streams that are available and drawing coherent conclusions from them is possible in a way that we've never seen before. So what do we see in the terms of wider marketplace and market development? We need to see these requirements for building performance evaluation to be embedded in standards. We're beginning to see that, and included in publicly funded projects. PAS 2035 is a good example, but also in Wales, the Innovative Housing Programme, which has been encouraging modern methods of construction, requires every property to be monitored and to have performance data captured. In terms of logistics, we need to start to get ready to train the people that are referred to in PAS 2035 as retrofit evaluators. And one of the key things there is, well, what skills do these people have and what standards do they work against? And that's why we're beginning to see British standards being developed for building performance evaluation. And that's so that we can align the work that those evaluators do with ultimately the people that will make this fly, which are the financial institutions and the mortgage lenders, who may in time say, a property has greater value to us, or we're much happier to lend on it if it has these data streams and this information coming from it. So one of the big projects we're working on at the moment is we're working with Innovate UK funding and BSI to write the first building performance evaluation British standard. The key things here are to make sure that whatever standard is created, it remains open enough to innovation so that it is valid and current. Because the last thing you want is a standard that takes 2 years to write, is published and is immediately out of date because it doesn't include some of the new technologies and some of the new data analysis techniques that Tom and Luke are actually working on. So that's one of our key interests, and also making sure that the guidance that comes out with the standard allows people to develop training packages so that we can create a team or an industry of performance evaluators that all work consistently in the same way that the Retrofit Academy are currently training PAS 2035 coordinators. So I'll leave you with a couple of questions. I think we've got a session at the end where we can pick some of these up, but I'd like to think that at the end of this event, not just from my presentation, you'll see that actually building performance evaluation, data monitoring, capturing, post-occupancy evaluation are becoming more and more mainstream for a number of reasons. One, a desperate need to improve quality, particularly in terms of retrofit, and also a parallel interest from the energy sector, which is if we're removing gas and we're electrifying all of our space and hot water demands from the built sector, and you overlay that with the electrification of transport, then understanding how buildings are performing, smoothing the peaks and the spikes of the energy that they need, and maybe even using them, they almost have the potential to be batteries, both for cooling and heating, but also for electricity itself, because a large battery put into a building is no doubt a lot more cost effective and easier to integrate than it is to do it with pump storage and lots of new lakes and dams and goodness of what else that you would use to produce that. So the questions really for you are, do you feel that it's time to help your team understand more about building performance and the technologies and the techniques that are out there? Would you benefit from doing a BPE exercise to increase learning? So with the people that you meet today and the people that you could meet through the network, it's quite possible to run quite small focused studies so that your team can understand how to use BPE to their advantage. Some of your clients might actually be very interested in this and come on the learning journey with you and help fund it. And maybe it's time to start building your network. At the BPN, we have a really positive outlook and a really good mix of people, from deeply technical academics all the way through to technology innovators, planners, policymakers, and property owners as well. So if you want a place to come where you can learn about what's happening, and in particular, you can find out more about the British Standard. The consultation is on its way in June 2021. If you'd like to be some of the first people to find out what's in the standard and take part in the events where we'll explain more, and you can get your chance to feedback on, does this make sense? Would it help your part of the industry, or would it actually cause more barriers to innovation? We would really love to hear some more from you. That's it from me. Happy to take some questions now, Rich, if you'd like to. Otherwise, we can do it in the wrap-up session at the end.
Yeah, thanks very much for that, Ross. Very interesting stuff. So have we got any? So we got one from Stuart. My experience with the household extension and remodeling market is that householders are already feeling inundated with services, architectural, structural, party walls, CDM. I agree. And an additional service I'm not convinced would be particularly welcome. I don't think there's anyone who could probably disagree with that. However, in the spirit of what we're discussing, this whole idea of does a building perform as it should, I see building performance evaluation as a positive for a homeowner, in as much as it will ensure, hopefully, that they are getting what they paid for. And I think if it's pitched in the right way and done in a light touch way, so some of the techniques that we're talking about today from Tom and Luke and that Ross has mentioned as well. So without a full team of scientists approaching the building to dismantle it and investigate it, then there's probably something that we could do for the homeowners. But I don't think we're quite there yet. But I think when this develops, and maybe when it's embedded into legislation and probably a bit more streamlined. So Ross mentioned the British Standard there, which I'm a part of, Luke's a part of as well. Then, I think these things might become more mainstream. But Stuart, I'd be the first to agree we're not quite there yet in terms of hitting it off with the householders directly. But I think it will come. I think it will come. Ross, do you have anything to add there? Yeah,
it's probably worth mentioning actually that in the PAS 2035 world, the role of the retrofit coordinator is to actually coordinate. Obviously, that's his name. What Stuart's described there, which is there would be a central person whose responsibility it is to make sure that CDM, structure, party wall, health and safety during the actual delivery of the project itself is all put in place. And there with the project from the very beginning, one of the challenges of that is who's going to pay for that, particularly if it's in a private one-house project, because the responsibility that person takes on is significant. So we're yet to see really how that service will be provided. but it seems like it's the most sensible way to go, because you need somebody who is kind of a technically competent project manager, even for individual house retrofits. But we see companies such as Parity Projects and others that do deliver that on a home by home basis. So it's beginning to happen.
Thanks, Ross. So we have a comment from Nathan. So Ross has mentioned Zero. Zero, quite a big name in all this, and they certainly do a lot of work in this area. In one of his slides, they will be sponsoring a season of my podcast. If anyone is interested, and Nathan's link is there. I listen to Nathan's podcast. I'd advocate that everyone gives it a listen and sees what they think. It's interesting stuff. Certainly interesting to me, anyway. Maybe Nathan, if we get 2 minutes at the end, you might kind of just want to kind of quickly do a plug for your thing as well. We'll see how we squeeze it in. And Colin, will the building performance activity result in there being natural feedback to the building services and systems to automatically optimize the building for different seasons? So Ross, I've got thoughts on that, but have you got any?
I'd like to be able to say, of course, yes, but who knows? We will see. I think time will tell, and it will depend on the type of building as well. If it's a really large hospital or an office where there's a facilities management team, you'd like to think it's happening already. Maybe it's not in the way that it should be. For individual homes, yeah, who knows? Let's see. I don't know what you think, Richard.
So I can say what I think. So we've done a lot of testing in the NG house and out in the field on heating systems and smart heating systems, optimized start, stop, weather compensation, and things like this. They always work a lot better if the units themselves are sized right and the gradient is set up properly on the boiler as well. That does make a big difference. Now, that's not to say that what we're discussing could go straight into that type of setup. But I think if we streamline, and Tom's session is going to give us a little bit more about kind of getting more or less an instant, very quick HTC for the building, I think that could be very useful for commissioning, which hopefully will help to optimize the building. Last one from Nathan. I've often thought about gamifying building performance among homeowners. I know some of the beta talk heating engineers will be interested in taking part. Ross is asking some assistance there. I'm sure Ross would be interested. I certainly am. And if anyone's interested in gamifying performance, you can contact me. So a little bit of a backdrop to that, Nathan, it might be interesting for people on the call. We did a study about how different engineers balanced heating systems. So we got them in, and we got from the people who were putting thermocouples on the hot and cold side to people who were just putting the hand on the top of the radiator and feeling it's hot, and everywhere in between those, and people using automatic balancing systems and things like that with varying different results. And it does make a difference, probably not as pronounced as we thought, but it does make a difference. And the idea of seeing how people do it differently is very interesting. So Nathan will probably drop your line on that. It's quite an interesting bit. Okay, so we practically banged on time. Ross, thank you very much for that. No more questions, and we're going to move over to Tom now. So Tom is from Veritherm. So Veritherm well, Tom will tell you exactly who they are, but it's a company that we've been working with probably for maybe 6 months, something similar, with this whole idea of validating and testing and examining a building performance test methodology. And it's a very interesting one, and I think you're going to find Tom's talk quite interesting, because it takes a different approach than we have in the past. So over to Tom.
Thank you very much, Richard. Right, I'm just going to share my screen. So if you can give me a nod that you can see that.
Yeah, we can see that, Tom.
Yeah, okay.
Make it full screen if you can, if possible. There we go. That's it.
Yeah, fantastic. Okay, thank you very much, Richard. Okay, so yeah, thanks to Richard, Ross and Luke for giving us some insightful presentations there. So I'm going to round off today's webinar with our Veritherm solution. So the brief I was given was to talk about Veritherm in the domestic retrofit setting. There are obviously applications with our technology in the new build market as well, so do bear that in mind. And I'm actually tuning in from Salford Energy House today, so quite fitting, really. So a little background on who we are. So we are a leading provider of thermal performance testing services and technology. And our Veritherm solution has been built on 70+ years combined experience in the construction sector. So we're very much industry people, building a solution that is for industry. We have seen our Veritherm system adopted on a wide range of UK housing projects. And we've actually got to a stage now where our technology is now available for industry professionals and organisations to use and capitalise on. So briefly, what is Veritherm? It's a one-of-a-kind system, as Richard has already mentioned, and it enables a rapid test to be performed at the sign-off of building work or at other times during a building's lifespan. And the Veritherm system can verify whether materials have been installed appropriately and the overall thermal performance, so combined U values of the building, is in line with the design specification. So we'll move on to that comparison a little bit later on. There's obvious benefits in helping to close the performance gap between design intent and as built. And obviously we are helping the UK to achieve its net zero obligations. So quite an important technology in the grand scheme of building performance evaluation. So this is very product focused today. I'm not going to touch on the performance gap at all, really, because I think it's been adequately covered. There is a gap. We need to understand it and minimize it before we can actually transition to lower carbon sources of heat and so on and so forth. So our system, its USP really is its speed. So it's very, very fast. So a Veritherm test is carried out in a single night and can deliver a result within 12 hours or less with regards to thermal performance of the whole building envelope. We've built a very scalable system, so it's a completely automated process which returns immediate and quantitative results. It's quite literally at the click of a button. And it's very, very simple. So Richard and others might tell me off here, but we're trying to remove building performance evaluation from the academics and get your hands on testing kit and equipment so that it can be carried out at scale across the UK. So our system is very, very simple to use and can be ran by a trained operator without needing any real specialist knowledge or experience in data handling, which is really the important part. And lots of people that I've spoken to have told me that the Veritherm platform itself that we will run through a little bit later on is one of the most advanced they've seen. And finally, it's very cost effective. So as Luke mentioned, industry standard tests that can take 3 weeks plus can cost in the region of £5,000 or more. Veritherm can deliver a reliable measurement of thermal performance from just £500 per dwelling. And we will look at the business model around Veritherm a little bit later, but we've very much modelled our approach on existing technologies such as air tightness and acoustics. So we fit right in with the existing ecosystem of building performance measurement. So you might be wondering how our system works. So it's quite simple. What we do is we deploy data loggers inside the property, typically one per room. Those are labeled so that we can actually look at the data plots inside the building. We also measure the external environment and we actually apply a controlled and measured heat load to the building, circulate air inside the property to ensure that the temperature is rising uniformly, and then we allow it to cool passively. And then our system takes over and processes all of that data and gives you a concise set of results, which we'll show you very shortly. So mainly it consists of preparation, so getting the design information, planning the test and deploying the kit. a measurement stage where we're taking all of that data, as I've mentioned, and then the system produces a set of validation calculations which are consistent with the measured data, and then we can make a comparison to the design specification, whether that's SAP or a heat loss calculation for a low carbon heating system, and you can actually get an accurate and fast measure of how far off you are from that estimate. In terms of product validation, we get asked quite a lot what we've been up to and, you know, does the system work? The system's been in development for almost 6 years now, so we've done a lot of testing and verification of our technology. As Richard mentioned, we're now engaging with academics to further evidence what we've already done. In terms of our Veritherm system, it's been tested on a wide range of UK housing styles, and it demonstrates repeatability. So what I mean by repeatability is we test the same building in different conditions and it will produce the same set of results. Accuracy and robustness to variations of environmental conditions. So we've tested our solution in different weather conditions, for example. So the conditions covered are a wide range of exterior temperatures. Typically, we need a 10 to 15 degree temperature difference for testing. We've tested it in different amounts of rainfall per night, as well as looking at varying wind speeds from around 3 to 33 miles an hour. So quite a wide range there. We've also made comparisons to the Veritherm system with the co-heating measurements, and in all observed cases, we've found a complete agreement there. So all of this information provides us, our clients, our customers, and our users with confidence that the Veritherm approach will operate successfully in common UK weather conditions. And further to this, Veritherm is a valid method for thermal performance testing on UK housing stock, more importantly. So this validation work has been carried out with our technical partners, Cambridge consultants, who specialise in disruptive innovation, testing and monitoring. So we have relied on them to help us with algorithm development, which Ross spoke a little bit about earlier on in the presentation. So in terms of co-heating, I've just plucked an example here, but this particular property we measured various times within the year, lots of different weather conditions, sun, rain, snow, so on, lots of different varying weather temperature conditions outside, so ranging from 2 degrees down sub-zero and then back up to around 10 degrees. And as you can see here, Veritherm has consistently produced the same set of results despite lots of different changing factors. More importantly, we've compared it and calibrated it against, I guess you could call it, current state of the art in the co-heating test, and found a complete agreement in our results. We will be publishing reports alongside Salford and our own validation study, which will include a lot more information about how Veritherm contends with long-term and short-term thermal characteristics, for example. So if I give you a brief insight in what I mean there, this first test was carried out when this building was newly constructed, so contending with wet materials, for example. This test was carried out when the building had been occupied, heated constantly for a period of 2 to 3 weeks. So it can contend with these types of factors with its dynamic analysis. I've mentioned Salford, so yeah, we're doing some work with the guys here at Energy House 1, so further independent validation of our testing method to give more confidence to our users and our clients. They're helping us with industry exposure, like today we're talking to you guys about our system and our technology and integrating us into existing housing schemes. And I know Richard is very keen to get some research papers out of the studies that we're doing at the moment, all of which are going to plan. So I'm sure Richard will be happy enough to endorse what we're doing here at the Energy House. We've sat down with government at the highest level who have endorsed what we're doing. So they've stated that Veritherm can help to reduce CO2 emissions from homes, reduce occupant bills, and help the UK to meet its carbon budgets. So as we've said, we're seeing slow changes to legislation. We see that happening in the next few years. However, Veritherm is all about showing the value of building performance evaluation without the need for mandated legislation and testing, which we'll move on to shortly. So I wanted to give you an overview of our platform itself, because sometimes, you know, we talk about all of this stuff, but you can't actually see what's happening and how it's conducted. So I just wanted to show you how easy it is to set up a Veritherm test. So I'm just going to talk over this kind of brief snapshot. But ultimately what we can do is we can enter in the client's details, which allows us to share our reporting immediately and digitally to our users and clients. We also give the property a unique 3-word reference, which is linked to the application What 3 Words. So we give each building an identifier, but that also pulls through the unique weather data so that we can include that in our reporting and results. We enter in some general building dimensions, which can be taken from the plans and then checked on site by one of our testing engineers. And we can also reference the design information that we've used, so whether that's SAP, and you can actually enter in those details. We enter in the air tightness test information, so we can understand what losses are attributable to air loss and infiltration. And then we can actually then put in the designed thermal value that we're testing against. So how well insulated is your building in comparison to the design. Enter in information about party walls, and then we start to add in more information so that we can actually take a statistical approach when our users and our testing engineers gather a wider and larger data set. So what archetypes are performing in situ, passive house, non-passive house, and we can actually look at that, and the platform has a statistical element to it, in that you can actually start to pull down those results and learn from it over a period of time. You can add in notes, which will pull through onto your reporting. So it's very, very simple. Other than deploying the kit inside the property, that's all that's required for a test setup. We'll then come through onto the dashboard, and our platform actually controls the times of the tests on the specified dates. Those can be adjusted if needed, but typically test starts when the sun goes down and finishes when the sun rises. So as I said, we deploy then temperature loggers inside the property, and these can be labeled by room. So you can actually pick apart the temperature data, which is very useful for sizing and balancing heating systems, as well as actually offering a fault finding kind of facility within the technology if a particular room or area of the building isn't getting up to temperature, or if it's dropping off quicker than others. So what we do is we label all the sensors per room that are in the property. You can link this with your designated testing kit, and then actually enable those data loggers so they pull through the data for the duration of the test, and actually the platform will control and allow remote monitoring for the evening. We also can label up the heaters that we use, as well as the fans that we use to circulate air, and that actually monitors the power or the heat load that we put into the property, as well as controlling when these items are turned on and off for the duration of the test. So I want to stress that the platform at this stage is very smart and capable, and we're actually putting building performance evaluation in the hands of industry professionals so that it can be used and conducted on pretty much any project very easily and efficiently, whilst capitalizing and using existing kind of site teams to deploy the test. Once the test is lodged, you can actually view the test running on your platform whilst it happens in real time. You can actually test the equipment, so test the heating system in the property for a period, make sure that you're seeing a gradual temperature rise. Then you can actually log back in whilst the test has started to see everything happening in front of you. And finally, what you do, you come back in the morning, click into your reports, and you'll actually see that particular test, be able to make a comparison against the design. So you can see the design and as-built thermal value, quantification of the performance gap, and then you can actually look at the raw data plots there and start to pick apart that data, whether it's for compliance, whether it's for sizing heating systems, it's all very important. And then there's a pre-populated certificate download, which we'll move on to now. So you can actually download the certificate and all of the information is there for you to look at immediately after the test is finished. So with our reporting, we tend to take a predicted and measured thermal performance value and make a comparison. We also give an average U value for the entire building envelope, which allows you to give back to your clients and projects. And we actually give a thermal efficiency rating for the building based on its size and heat loss. So a bit like Luke's heat loss parameter, we take a similar approach there. And we actually start to quantify the performance gap as a percentage for thermal efficiency, because we actually feel that when you're translating this information back to clients, it needs to be put in layperson's language. Nobody knows what HE is. This information needs to be tangible and digestible for the layperson, which we've done a lot of work on over a long period of time. Future things that are coming into the platform in a matter of weeks, actually, is there'll be a long version of this report pre-populated post-test, so you can actually pick apart the data by room and see lots of other bits of information. We're working on quantifying the cost and carbon impact of that result and actually putting this result into pounds and pence, for example, so you can translate that information back to your clients and customers. And also statistics and data consolidation, which I've talked about. So allowing councils and housing associations to see how the performance gap is coming down over a period of months and years across project to project. Because ultimately this is an iterative process, and Veritherm gives you that information over a period of time to see gradual improvement over different housing projects and schemes. So yeah, it's quite robust and useful at this stage. So I'm going to talk about how Veritherm can be useful for retrofit settings mainly today. Obviously, there's lots of good use cases in the new build sector, but we can talk about that outside of this call if you want to get in touch. But ultimately, in retrofit, Veritherm allows you to understand the thermal efficiency before your project. So you can measure the building and establish a baseline. You can then measure retrofit and fabric upgrades during your whole house retrofit. So when the floor insulation goes in, you can take a Veritherm measurement. Then you can take a Veritherm measurement when the external walls go in. And all throughout the process of the project, you can actually see where you're at with regards to performance, which is very, very important and actually helps you close the gap because you're justifying your strategy. Anything that can't be rectified can then be learned upon for future projects. So it's quite good in that sense, and it actually won't really damage the timeline of the project because it happens overnight. So, you know, by the morning, the kit can be removed and onto the next fabric upgrade, you could say. It's quick, so you can check the standards of your own work and that of third-party contractors. Allows you to make informed decisions based on real-world performance data, whether that's sizing heat pumps or whether that's are we using the right materials and systems. Allows you to identify problems before the building is handed over and signed off, because then obviously there's future problems. So it kind of mitigates those future issues so that you don't have issues post-occupancy. Finally, and most importantly, it allows you to understand the performance gap within your projects and your organizations. So very, very important there. Just going to give you a couple of snapshots into some projects that we've done over the last couple of weeks to give you some, real-time information of what's happening on the ground. So this particular property we measured mainly for the purposes of conducting a heat loss survey for a heat pump installation, but mainly to understand how the fabric was performing pre-retrofit. So the homeowner contacted us. I think Nathan, who's been talking on the call today, has actually integrated us with that. So thank you, Nathan. And Guy has come back and basically said the process allowed him to have a real insight into the leakiness of his house and blew away traditional calculation methods of fiction. So as we know, modelling exercises are almost always wrong. It depends which way you can go, but they're almost never accurate. And as a result of the test, he was in a much better position to design an air source heat pump on this occasion to suit the building's needs and that works for his home. So on this particular property, the thermal performance of the building was kind of oversized to compensate for the unknown. So we actually enabled around about a £3,000 saving on the heating installation, as well as saving on operational costs. So, you could say that the Veritherm test was probably the best money spent on this particular retrofit project. We're working with other partners and testing engineers. So these are people who actually have testing capabilities in-house. So this is a particular retrofit coordinator that has Veritherm testing capability. We can actually quantify retrofit upgrades on large retrofit projects for councils and housing associations. And what they really like with Veritherm is the speed. So they can actually get next day results and instant feedback on performance at various stages of the building process. And it allows them to see quality assurance as they go, and kind of drives this get it right first time delivery, which is ultimately really important. So, measuring things is great, but how can we actively try to resolve and minimize this performance gap from project to project? And then finally, Ross has spoke about values to different people and stakeholders within in the sector. We've been doing quite a lot of work with product manufacturers. So what impact does your particular product have on the overall performance of the building? Let's quantify that for you, make improvements, and then once you've got it to a stage where you're happy, you can then actually use it as a marketing tool to say that, my products are performing in situ and they're making this amount of improvement to the overall building performance, which is, quite powerful when there's lots of emerging products that really kind of we're unsure about and haven't had that kind of testing and verification process in situ. So Paul here said Veritherm gives the building a voice, helps you to better understand what's required, and basically for retrofit it's hard to see why you would test any other way. So these are real clients and real partners and testing engineers that either have Veritherm testing capability in-house or have used us to actually conduct testing services. We have a growing network of approved testing engineers across the country. So these are made up of retrofit coordinators, air tightness testers, thermal imaging surveyors, domestic energy assessors, which basically means that anyone can get hold of a Veritherm test quite cheaply at any region within the UK. But in terms of people who are interested in maybe becoming a testing engineer and selling the service to your clients and your projects, you can earn somewhere between £400 and £650 every time you test. So it becomes quite a lucrative service to offer, even though it's still very cheap for your clients to actually get this data. You can add our highly innovative and unrivaled service to your business, stay ahead of your competitors, and help to increase your revenue and help the UK to meet its climate change commitments. So we're seeing this grow quite rapidly. We are very pleased to see the appetite out there for our solution. It was deployed earlier this year. We also have an array of testing partners that have come on board. So these are organizations that are looking to test your own buildings, products or services. So once you've invested in the technology, it becomes very, very affordable to deploy it at any time. So once you've invested in the kit and the software, you just pay £100 lodgement fee onto our system. So it's then very affordable to do this throughout your retrofit projects, as well as quality assurance thereafter. It gives you autonomy, so you can actually control and manage the performance gap across your estate. And really kind of push towards this net zero target that we're all talking about, and then obviously benefit from huge cost savings as well. So what we've been doing, and I think Ross mentioned it, but you know, we offer training and support, so we're upskilling the nation, you could say, in the use of the Veritherm technology, with hands-on practical experience with the kit, as well as theoretical delivery with using the software and understanding the general concept of building performance evaluation. We've partnered with the Building Performance Hub, so we're using their new facility to deliver training courses, but we're also due to release some new course dates that will happen in the Midlands, in Birmingham, as well as up in the north in Scotland. So there's a training available to everyone, and our next dates are mid-May, so if you're interested, then please visit our website and we can have a look at spaces for you. So in terms of our system, you know, that's us. We measure insulation performance in situ, quickly, cost effectively, and our platform and solution is available to for anyone to use, deploy, or sell to your existing contacts and networks. So I think that's it for now, and thank you very much for listening.
Thanks, Tom. Spot on time as well. Excellent. So we have a couple of questions. So the first one is from Matt. Is Veritherm able to be used for retrofits and or existing buildings? I think Tom answered that a bit later on after you asked it, but Tom, if you want to elaborate briefly.
Yep, so we're testing new buildings, existing buildings, post-retrofit buildings, so it does apply to lots of different housing types and schemes. The building does have to be unoccupied, but you know, as we've alluded to earlier, for whole house retrofit, they tend to be out of the property anyway. We've seen instances where tenants have been decanted, people have moved out for an evening. So actually, in terms of the occupancy bit, we found that it's not actually been an issue at all, to be honest.
Okay, excellent. Colin, will this measurement method work with MVHR? Also, will it work with PIV, positive?
So yeah, we don't measure ventilation losses. So we test a sealed space. So Veritherm is very much looking at insulation performance of the fabric rather than total heat loss. So, you know, there's monitoring applications like Luke's where you can look at whole house heat loss, but we feel that understanding the insulation quality of your home is a key piece in the puzzle, should we say.
Okay, thanks, Tom. You cut off a little bit there, but I maybe me. 1 second. Okay. So do you see Veritherm as an alternative to an EPC, i.e. measure the thermal performance of a dwelling that's independent of the vagaries of how the occupant behave?
Yeah, so we test at a building level. So let's remove the occupant and strip out that variability so we can understand the quality of the building. In terms of replacing EPC, I think we can actually just filter our information into SAP and similar modeling tools. So yeah, I think in terms of replacement of EPC, we actually want to start inputting our data into existing modeling tools to better understand as-built performance. I mean, there has been talk about replacement of EPC, but I think inputting real-world measurements opposed to theoretical values is the way to go.
Yeah, I think from the discussions we've had with government, Michael, sitting alongside the EPC seems to be more palatable at this stage.
Yeah, with SAP, I mean, you know, you have the as-built SAP. So really, if you've got the measured values, those should go in at that stage, a bit like your air tightness results. We see Veritherm, you know, doing the same thing, basically.
Okay. Is there an implication in nighttime testing that there's little value in passive solar design? So because we're not taking into account kind of overheating and things like this.
Yeah, I mean, you can do other studies and evaluation methods to understand that. So again, we have a USP and we're sticking to it in that let's look at the insulation performance, strip out the variable factors. So solar irradiance and stuff does play a part, but we want to just, you know, strip it back to basics really. If overheating is a huge problem in the industry, but I think that needs to be judged on its own merits as such.
Yeah. Nigel Blanford sensibly asked, can a cat stay in the house or does that need to vacate?
I mean, if they like it quite warm, if they can cope with 25 degrees, then, you know, they should be fine.
Okay, so yeah, a cat that's well acclimatized, Nigel. Thanks for your question. So Colin, so he's put, Tom, does that mean that you're not measuring air tightness? I thought you mentioned air tightness and acoustics at one point.
So we don't personally measure air tightness, but our approved testing partners tend to be air tightness testers and acoustic testers. So, you know, this is a service that will sit alongside those existing services and kind of fit in. So the air tightness result, if available, goes into our platform. We personally don't measure it, but our users.
But it's fair to say that it's not explicitly measured. But if a house is old, leaky, and full of holes, then the HTC that you measure will be representative of that lack of air tightness.
Yes, yes. If we have, yeah. If it's not measured, we measure that value. If it is measured, then we can basically split apart the result and tell you what's air loss and what's fabric.
Yeah, so I think what we're getting at there, Colin, is that it's not separately measured. It's a lump figure, which may or may not be useful. But a blower door is a kind of standardized test now anyway. So the chances are that may well be added. So I'm going to add a couple of questions, Tom, because I'm interested. Okay. First of all, do you find that furniture has ever made a significant difference when you're carrying out a test?
No, so we can contend with thermal mass inside the property. So yeah, we have things within our algorithms and models to contend with that. So we test buildings furnished, unfurnished quite frequently.
And is there any development, and maybe this one can go to Luke as well, is there any development that's looking at room by room heat loss? I know you said you got temperatures, but is there anything that you're looking at a room, let's say a room HTC, a room heat loss value?
We get asked for it all the time. So yeah, I mean, I think we need to look at it in more depth. We're trying to pick apart the room by room data more and more as we see the heating industry coming towards us and asking for this type of information. So there's a bit of value in the raw data plots as they stand, but we're going to be doing more work to kind of improve on that, certainly.
Yep. Okay, so that's all the questions. So I'm willing to open the floor. Maybe Luke, as I open the floor, have you got anything to add to that room by room HTC that I was mentioning?
Not a great deal, other than it's obviously an area of interest. It's really tricky factoring that kind of the exchange of heat back into the rest of the house. So obviously you've only got a fraction of the room that's outward facing on the heat loss. So really insightful stuff just from temperature profiles alone, RH as well. But yeah, area of interest, but not something we can currently do either.
Okay. So I've got a question for the group just to kind of prompt some discussion. I won't labour this because we can have an early finish if we fancy it. But where do we see the future of building performance evaluation in the next 1 year and the next 10 years? Luke, you kick off because you're already at the middle of my screen.
Sure. For me, it's just got to be ramping from a very, very low baseline of very few measurements to something that's increasingly representative of what we're doing, whether that's new build or retrofit. So just as we've seen with air tightness testing, it began as a sample-based regime, and just this year has become 100% sampling because it's demonstrated itself to be extremely valuable, and there has been a notable kind of uptick in the industry's ability to build more airtight, more efficient building fabrics. And same applies for measuring thermal performance and other elements, is that the more we measure, the more we can learn, the better, the more we can improve. And certainly that immediate kind of 1-3 year kind of horizon just has to be measuring more and more buildings.
Okay, Ross, what about an industry point of view? Where's the BPN taking us in the next kind of couple of years and 10 years?
I'll speak for me rather than the whole network, because that's easier, isn't it? I won't get letters of complaint. I would like to see the whole of kind of part L and part F, so ventilation and energy use in buildings, move in the same direction as we saw part E for acoustics. And by that, I mean some scheme equivalent to robust details that's parallel to more onerous everyday testing and validation of performance on site. So I think we'll see it. I'd like to see a tiered kind of regime, so you can have your whether it's your fabric system or your entire build system, if it's a new build, tested to a greater level, so it's kind of pre-certified for building control, and then you retain membership of that certification scheme by having a number of more detailed forensic tests, a certain percentage each year, and by doing that you keep quality consistent. That's where I'd like to see it go. And I think a lot of the technology that we need, as I kind of alluded to, will be we'll get as kind of by accident from other industries that want levels of data and stability and quality of data that is beyond our imagining. So in the same way that, you know, PVs are an offshoot of the space race, arguably, and aerogel, and we happen to inherit it in construction, I think there'll be lots of technology-based things that will come our way that will mean in 5 years' time the things we're discussing now as being cutting edge will seem very basic.
Okay, yeah, I agree with all that, Ross. It makes perfect sense. Tom, what do you think? What lies ahead?
I'll keep it short. I think uptake for building performance evaluation has skyrocketed over the last 12 months from our perspective. I think now that you see technologies here today that enable people to do it cost effectively, gives you the opportunity to get on board with it now and get a clear insight of where you're at. Because I think, like Ross and Lucas said, that it will become mandated, I think, within the next 3 to 5 years. But the opportunity is there now to add value and learn from it before it's almost too late, you know.
Okay, so now we'll take some questions from the group. Who's got any questions for the panel as a final?
Sorry, sorry, can I just come back on that?
Of course you can, yeah.
Your last point. Again, not being an academic as I'm not, all the data you're collecting is very fine. It's good, but until, in my own mind, until a solution is found where a short payback period is given to the client to insulate the house, whatever it happens to be, whatever system somebody manages to invent, that all your data, unfortunately, will remain data.
Yeah, it's a fair comment, Mike. Stuart, sorry. I think what we've got to keep in mind is that, you know, I was a chartered surveyor before I started here, you know, so I've been I came out of that building physics I started building physics about 15 years ago, became an academic about 10 years ago. And in the last 10 years ago, no one was dreaming about testing buildings like this. You know, it's as simple as that we were just doing really hard building physics tests, filling vans up with equipment and going on the road doing this type of thing, sticking lots of things onto walls and things like this. Now, I think in the last 7 years that's become a lot better. And I think if legislation changes, I think that might accelerate even quicker. But you're perfectly correct. I mean, it's a young industry, but hopefully we can see it going places. But we do need government buy-in as well. You know, that's going to help. I think everyone needs government buy-in. Particularly the construction industry doesn't do anything without some kind of legislation changes. So yeah, hopefully we'll improve that. It's a fair point. It's a fair point.
You might get on Dragon's Den.
Yes, yes. Yeah. Hopefully not. Any other questions from the group?
I think there's one in the chat about roles for NHBC and quality mark.
Well, there you go, Tom. You pick up on that. You spotted it.
Okay, yeah, I think there are roles, but like you say, if there's a united kind of effort to report everything in the same manner and you know, do things in the same way, tie all of these different technologies together so that they're kind of, you know, concise and move from one to the other quite seamlessly. I'm conscious that there's a lot of schemes that arise and, in my opinion, don't really help the situation. We're actually trying to develop our own scheme, so we become, you know, we ensure our testers are competent, etc. And whether that ties into other quality schemes, you know, we'd definitely be keen to look at that.
Yep, no, I would agree. Luke and Ross, have you got any kind of comments on that? I think Tom made sense there.
Yeah, just to add, obviously, home quality marks are voluntary standards. So, like BREEAM, like Passive House, AECB standards, I think it's well placed to go before regs. So it can introduce new requirements, new standards before, sort of ahead of kind of what normally takes a long time with kind of policy and regulation development. So I think that's quite an interesting one, and I think they do have a role to play. NHBC is obviously an insurance warranty provider, and yeah, you'd like to think it's in their interest to potentially reduce the risk profile or perhaps premiums for customers if people have been prepared to kind of measure and demonstrate the quality of the building. So again, I think there is an industry lead that could be played there with insurance warranty providers ahead of wide-scale kind of regulatory kind of.
Okay, thanks, Luke. Ross, you got anything to add to that?
Just to say, it's interesting if you follow that chain of thought that the NHBC and the warranties that they provide are often critical to whether a mortgage will be lent on a property or not. And the discussions we as a network have been having with the mortgage lenders is that there's a new, I don't know if it's regulation or it's a kind of an acknowledgement of their kind of carbon moral relationship with the portfolio of buildings that they lend, that they have to publicly account the climate impact of their buildings. This sounds very far away from putting heat flux onto a wall, but actually a lot of the larger lenders are saying that they want really detailed information about the performance of both new build and existing stock that they lend against. So you might actually see kind of a very strange financially driven virtuous circle, that the people that lend have an interest in the performance of the building, maybe even more than the people that have built it. So yeah, we may see that change, and it fitting back to the question, yes, NHBC in the role that they play for warranty and building control and therefore quality, absolutely, it sits at the middle of this.
And just to take that even further, you can you only have to look at kind of the automotive sector and cars, their declared emission rates, their declared miles per gallon linked to tax, and whether that's in housing stamp duty or even interest rates on financial products. Yeah, there is a really interesting kind of set of levers and things there that yeah, I would say, and I know we've talked a lot today about HTCs, HLPs, and what does that even mean for a customer, but you'd like to think that eventually we can get it to a point where yeah, it's very similar to miles per gallon in a car. None of us put gallons of fuel in our car. I don't even know what miles per gallon actually translates, but you know what the number means. And I think the same should hopefully in the coming years be able to be said for HTC.
I think also the ultimate kind of quality mark, which all of these schemes are based on, is the measured value. So, you know, that at one point or another, they're going to have to get on board with performance measurement and actually getting insight into those values.
Okay, thanks everyone. So I think we're going to draw it to a close now. I'm going to just bring Nigel in. Nigel's just going to tell us all what the next session is about next week. And are you there, Nigel?
I am indeed. So thank you very much to everyone so far, especially for Richard for leading the session. It's up to me next week to take it forward with low carbon heating. So you've learned all about the fabric and how to measure it and what you do, but you're still at the end of the day left with a heating requirement in that building. What direction are we going in? We know it's very electric, and we also know there's something about heat networks there as well. So we have got a range of speakers. Nathan, who is out there somewhere, will be speaking. The award-winning Nathan Van Gambling, winner of the 2021 Renewable Energy Association Communication Award. We have as well Dave Kemp from Procure Plus, very, very knowledgeable, especially with the deployment of heat pumps within social housing. He'll be talking about some of the case studies. We're probably one of the longest standing people with ground source heat pumps is Andy Louth, very heavily involved with the Ground Source Heat Pump Association. He showed me his presentation. I looked at it. He said, how can I improve it? And I said, there's not a lot you can put in there. He goes, there must be something, there must be something. I said, have you got any shots of really bad stuff you've come across when you've had to fix people's, another installer's put something in? And he says, yeah, I've got lots of them. So you'll see lots of nice ugly shots hopefully in Andy's presentation. We've then got Vital Energy, who are locally based people doing district heating, so they'll be giving a presentation on district heating, and not just the technology, but also there's a thing where you've got multiple occupancy about how you charge for these things with heat meters, etc. And then finally you get the rough end of it, which is me mopping up on all the rest of the low carbon heating, which is, I'm a biomass specialist, I like to burn stuff, so you'll get a bit of that, a little bit about green gases as well. And maybe the more controversial part is that yes, we're shifting towards that electrification of heating, but you know, there's some big players out there that have got a lot of money invested in the ground in infrastructure. Are they going to just lie down and accept this, or will we see you know, a big push on green gases? So that's a little snapshot for next week. And I don't know whether Nathan's still there, whether he wants to give a little plug as well for his Beta Tech podcast.
Can you hear me? Yeah, so Beta Talk, BETA Talk, all one word, Beta Talks. That's the podcast I run. Quite a simple affair, really. I just wanted to amplify the voice of heating engineers. Obviously, it's kind of the first time in the history of central heating, which is a new industry. So sort of 60s onwards, we start to put central heating into homes. But as the discourse widens around heating our homes and sort of the emissions that produces, I did notice when I was on the speaking circuit that no one's actually listening to the on the coalface, on the ground heating engineers. And there's some fantastic heating engineers out there. And they're the ones that are day in, day out dealing with the technology that we're all talking about. So basically my podcast was set up to sort of amplify and disseminate their voice, because it's there's no hidden agenda with their voice, as we can probably see with other sort of cohorts. And so, yeah, you can always find that as Spotify and all the other ones, Apple. And I'm looking forward to speaking to you all next week about heat pumps. Excellent.
Thanks, Nathan. What we're going to do now is just we'll push the button on the voting, and we'll see if anyone's thinks they've learned more now than they did at the beginning. So hopefully that will be the case. So excellent is yeah, we are doing better. Yeah, there's more have got a very good understanding by far. Certainly more have got a good understanding. Very good. I think that's been worthwhile. That's great results. Okay, and we've all learned about the most important fact of the day. The take-home fact is that when you're doing a very therm test, you can keep a cat in the property. So thanks to Nigel for that. I presume, Nathan, he'll be asking you a similar question about cats and air source heat pumps next week. And we can look forward to that. So just check there's no more questions popped up, which they haven't. So 8 minutes ahead of schedule, but I think we've done okay. I think it's been really interesting. Thanks everyone for speaking. Thanks everyone for coming along. And I think it's been really interesting. So hopefully we'll see you all next week. Looking forward to that. Some green tech and renewable heating services. It should be pretty good stuff. I'm looking forward to it. And yeah, see you all next week. And take care. Thanks very much.
Thanks a lot.
Bye, guys.
Bye for now. Thank you.